Questions 5 through 7 on the 2003 Grade 12 Euclid Math Contest. In a series of odd numbers 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and so on, the signs alternate every 3 terms as shown. What is the sum of the first 300 terms of the series? You have plus 1, plus 3, plus 5, and then minus 7, minus 9, minus 11, and then every third terms, the plus and minus alternate like that. So we have to figure out the sum of this for the first 300 terms. So we basically have to group these. First, I'm going to group, of course, the positives, then the negatives, the positives, the negatives, and so on, like that. And if we do it for the first few, we should get some sort of an idea of a pattern. So if I add up the first 3, I get 9. The next 3, I get negative 27. The next 3, I get positive 45. The next 3, minus 63. And then positive 81. And then, of course, this keeps on going. Now, I want to keep a tally here. It's very important of the number of terms, because that's going to be very important at the end when we have to figure out the sum. Now, at the very first line, the number of terms was 300, right? Nothing's changed. But now something has changed. I've grouped them into 3 and I've added them. So now I have only 100 terms remaining. So that's very important to recognize. Now, at this point, do I have any kind of a pattern? Well, it looks like it, right? 9 times 1. This looks like minus 9 times 3, 9 times 5, minus 9 times 7, plus 9 times 9. So it does look like there's somewhat of a pattern. Okay, so the first thing, since there's a 9 everywhere, I'm going to factor that out. So I'll get 9, and then I'll get 1, minus 3, plus 5, minus 7, plus 9, and so on. The next term is most likely negative 11, and so on, like that. Okay? And then now I will group these again into 2s, like that. And you will see when you do that, you'll get minus 2, minus 2, minus 2, like that. So all of those will become minus 2. Now, we got to go back and look at the number of terms, because that's going to help us. At this point, there was 100 terms, correct? And at this point, there was also 100 terms. Nothing changed. But then when I factored it out, everything was fine. But now I've grouped them into pairs, right? A pair here, a pair here, a pair there. If there's 100 terms and I've grouped them into pairs, that means there are 50 pairs. Right? Because each pair has 2, and there was 100 terms to begin with. Now in this one, I've got 9 times minus 2, minus 2, minus 2, like that, right? So each of these 50 pairs equals minus 2. So that's going to help us figure out this calculation. So that means this is going to be equal to 9 times 50 pairs, and each pair is equal to minus 2, like that. So this is 9 times minus 100, which is negative 900. And that is the sum of the first 300 terms of that series. A 2-digit number has the property that the square of its 10th digit plus 10 times its units digit equals the square of its units digit plus 10 times its tens digit. Determine all 2-digit numbers which have this property and are prime numbers. So we've got some number, A, B. Those are the 2 digits, and it's obviously a 2-digit number. And it has this interesting property. The square of its tens digit, which is A, plus 10 times its units digit, which is B, is equal to the square of its units digit, which is b squared, plus 10 times its tens digit, so plus 10a. So basically took the information in the question stem and wrote it into a mathematical equation. So this is what we have to work with, and this is how we're going to figure out the numbers that they ask for in the question. So let's rearrange this. I guess a squared minus b squared, 10a minus 10b on that side. If we factor this, we'll get a minus b, a plus b, and this side we can factor out a 10, and this is about as far as we can get. I really don't know what else we could do here, but this does help us in some way. The a minus b's cancel, and that just gives us a plus b is equal to 10, correct? So if we can figure out all the possible two-digit numbers where a plus b is equal to 10, that will be a solution. But be careful not to omit a minus b. I crossed it out, but after I crossed it out, I realized, you know what? A minus b, if it's equal to 0, that's also a solution. Both sides would be 0. So we have to also figure out all the possible two-digit numbers where a minus b is equal to 0. So that's another set we're going to have to figure out. And a minus b equals 0. That actually means something, right? It means that a is equal to b. So I think that's easier to look at than a minus b equals 0. So there you go. We're going to have two sets of numbers. First one with this condition, second one with this condition, and then at the end we have to pick the ones that are prime. First, let's start with a equals b. I think that's easier. If a equals b and you want to make a two-digit number, that means we got for a and b, right? We've got 1 and 1, 2 and 2, like that, 3 and 3, 4 and 4. A has to be the same as b. That's our condition. So there you go. These are my numbers. Okay? Now, I have to only choose the ones that are prime. So in this list, which one are prime? I think the only one that's prime is 11. Everything else is a multiple of 11, so it can't be a prime. All right, let's now look at this list here. A plus b is equal to 10. So that means a and b, 1 and 9, and then 2 and 8, and so on, right? 3 and 7, 4 and 6, 5 and 5, 6 and 4, 7 and 3, 8 and 2, and finally 9 and 1. So our number is just AB, so the way I wrote it, it kind of becomes the number in a way. It makes it easier for us that it kind of turns out that way. So now of this list we have to figure out which ones are primes because they only want prime numbers. Okay, I think 19 is a prime, 37 is a prime, and I think 73. 91 is divisible by 7, I think. So there you have it. The ones I circle in red meet all the conditions of the question, including the fact that they are prime numbers. So we've got 11, 19, 37, and 73. And that's it. So these are the two-digit numbers that have this property that they mentioned in the question. A lead box contains samples of 2 radioactive isotopes of iron. Isotope A decays so that after every 6 minutes, the number of atoms remaining is halved. Initially, there are twice as many atoms of isotope A as of isotope B, and after 24 minutes, there are the same number of atoms of each isotope. How long does it take the number of atoms of isotope B to halve? So you have isotope A and isotope B, correct? And the first one has a half-life of 6 minutes, and they want you to find the half-life of B. So let's just say we have our initial conditions as A1 for the number of atoms and B1 for the number of atoms of B. And they tell you that initially there are twice as many atoms of isotope A as isotope B. So that means A1 is equal to 2B. And then later they tell you, after 24 minutes have passed, that there are equal, same number of atoms in both A and B. So that means after 24 minutes, I'll call it A2. A2 is the same as B2. Those are basically the conditions. So let's start off with A1. We've got A1, and we don't know how many there are. So A1 is basically our number. After 6 minutes, it halves, right? Because its half-life is 6 minutes. So after 6 minutes, you have A1 over 2, the number of atoms. After another 6 minutes, so now we're at 12 minutes, it halves again. So now we have A1 over 4. After another 6 minutes, which is 18 minutes, it halves once again. Now we're at A1 over 8. And finally, another 6 minutes go by and it's 24 minutes. It's A1 over 16. Now A1 over 16 is basically what is A2. So I'll write that over here. A1 over 16 is equal to A2, because that is what we have after 24 minutes. All right, so that takes care of A and A2. Now let's turn our attention to B. Initially, B1, we don't really have a value. All we have is just B1. Okay, no problem. So B1, we know from this equation, is equal to A1 over 2, if you just manipulate that equation a little bit. So this is A1 over 2. Now, we don't know the half-life. So instead of writing 6, 12, 18, 24, since I don't know the half-life, I'll just write 1 half-life, like that. 1 HL, 1 half-life. After 1 half-life, this would become A1 over 4, correct? After 2 half-lives, HL, it would become A1 over 8. And after 3 half-lives, it would become A1 over 16. Now, this A1 over 16 is important. Why? Because it equals A2, as we previously concluded. And then A2, from this equation, you will see, is equal to B2. So that means A1 over 16, which is equal to A2, is equal to B2, since they were the same. That's what the question tells you. So we can conclude from that that B2 is equal to A1 over 16. So now, to go from the initial B, which was A1 over 2, to go to B2, which is A1 over 16, how many half-lives? Not the amount of minutes I'm asking just how many half-lives. Well, it was 1, 2, 3 half-lives. So it took 3 half-lives to go from B1 to B2. Now, how many minutes is each half-life? Well, how many minutes did it take to go from B1 to B2? 24 minutes, correct? 24 minutes, and that represents 3 half-lives. So each half-life for B is 8 minutes. So that is what they're asking. How long does it take the number of atoms of isotope B to half? It will be 8 minutes. Solve the system of equations. So we have the log of x to the third plus the log of y squared is equal to 11. Now, since it's base 10, I'm not going to write the base in every time, because in log questions, if you don't write in a base, it's always assumed that it's base 10. It just saves me and saves everybody some time. So this is basically equation 1, but the log rules help us. We can bring the 3 out front like that, and we can bring the 2 out front like that. And I'll call that equation 1. And then from my second equation, that one, I get log x squared minus log of y to the third is equal to 3. And very similarly, log of x minus 3 log of y is equal to 3. And I'll call this guy equation 2. All right? Now I just manipulate these two equations and try to solve for x and y. So I think if I take 2 times equation 1 and subtract from it 3 times equation 2, it will help me get rid of the x's. So let's see what we get. 6 log x plus 4 log y minus 6 log x plus 9 log y. And on the other side, it will be 22 minus 9, like that. And as planned, the x's disappear, and I get left with 13 log of y is equal to 13. So that means the log of y is equal to 1. And now I'll put in the 10, just to make things a little bit more clear. And based entirely on the rule of logs, 10 to the power of 1 is y. Okay, so there you go. There we've got our y. And we have to now solve for x. Now solving for x, you can just substitute the value of y into any one of these, and that should be sufficient. So let's do that. We'll sub it back into, I guess, this guy. We have the log of x to the power of 3 plus the log of y, but y is 10 to the power of 2 is equal to 11. So it means log 3 log x, like that, is equal to plus 2 log 10 is equal to 11. And 3 log x plus 2, the log of 10 is equal to 1. So 2 times 1 is equal to 11. So 3 log of x is equal to 11 minus 2, which is 9. And therefore, we've got the log of x is equal to 9 divided by 3, which is 3. And now I'll put in the base 10 just to make things a bit clearer. And then based on the rules of log, 10 to the power of 3 is x. So there you go. Y looks like it's 10 and x is 1,000. So my solution to this system of equations right here is x, y. X was 1,000 and y was 10, like that. A regular hexagon is a 6-sided figure which has all of its angles equal and all of its side lengths equal. In the diagram, ABC, DEF is a regular hexagon with an area of 36. The region common to the equilateral triangles ACE and BDF is a hexagon, which is shaded as shown. What is the area of the shaded hexagon? So here is my diagram blown up a bit, and this is basically the diagram that I'm going to work with. And the first thing I'm going to do is break this into regions as follows. I'm going to join a bunch of lines, and when I do that, I hope you see that we can break this up into a lot of regions that are the same, just like that. And you will notice, I hope, that these are all equal, these triangles that I created. And I'll just label them A, like that. And very similarly, this is A. And so is that, that, and that. And then the only other region is this guy, this sort of bigger triangle, and I'll call those B. Those are all identical based on the fact that this is a symmetrical diagram because it's a regular hexagon. All the sides are the same, angles are all the same as well. So that's the first step. And of course, I have to label the side length because they don't give me one, so I'll just call it X. All of these are X. It's a regular hexagon. So all of the sides are the same, all the angles are the same. They tell you that actually in the question. So there you go. That's the first part. Now the total area of this entire shape, they tell you, is 36 right here. Now, in terms of my A and B, what is it? Well, how many A's do I have? I've got 12 A's. So 12A. And how many B's do I have? I have 6 of those. So 12A plus 6B is equal to 36. I can simplify this a little bit, divide through by 6, and I'll get 2A plus B is equal to 6. Okay, so that's the first part. I hope you are convinced of that. And if so, we can now move forward. Now what I need to do is, for each of these, I have to find the area in terms of x. Because I have to eventually solve for a numerical value. When they say find the area of the shaded region, they don't want the answer in terms of x or in terms of a and b. They want an actual number. Like the total area is 36, so what is the area of the shaded region? Is it 3? Is it 20? So like that. So now my goal is to get the area of a and b in terms of x. And then once I do, I'll plug them back here and solve for x. And then I can figure out the area of the shaded region. What is the area of the shaded region, by the way? AS. It's 6A, right? It's just those A's that I drew. All right, so here we go. Now I blew this up a bit because I want to concentrate on certain regions here. Remember, I call this region A, and I call this region B, if you remember. Okay? Now, I want you to understand that A, C, E, this guy right here, they tell you is an equilateral triangle. And since it is, that means this angle is 60 degrees. Okay? And they also tell you the same thing about BFD, that that's also equilateral. And therefore, this is also 60 degrees. Now, this angle in here is a right angle, correct? Because you're going straight down from B to D to make that angle. So that is a 90-degree angle. But this guy in here is 60, so that means by subtracting 60 from 90, that's 30. Okay? And in a very similar way, this is 30 as well. And then what I'm going to do is I'll draw a perpendicular from AB down to this point right here. And when I do that, that becomes a right angle, like this. And therefore, this angle in here is 60 degrees. So now we have a 60, 30, 90 triangle, and we can work with that. Instead of making the diagram all cluttered, I'm going to draw that 60, 30, 90 triangle on the side like this, and then we'll work with that and try to figure things out. Now, from A to B is what? Well, we don't know. We had labeled it x. So therefore, from here to here is x over 2. Because it cuts AB in half, this green perpendicular right there. Now this is a 30, 60, 90 triangle. And by now, you definitely know that the ratio of the sides are 1, root 3, and 2. So if those are the ratios, we can figure out the other two sides in terms of x. I'll call this guy, let's say, h, right? Why not? And this side, we don't really need, but we can figure it out later. But one thing is for sure, since we have these two, and we know the ratio of the sides, x over 2 over h is the same as root 3 over 1. Okay? And that means that x over 2 is equal to root 3h, and therefore h is equal to x over 2 root 3, like that. So I believe that should be enough to figure this out. So let's go with this. I'm going to draw another line on the diagram from this point till there. and that's going to represent the height of the triangle when I figure out the area of this guy right here. And that is, you can see in the diagram, since it's exactly from there to there, it's equal to x over 2, that length. All right, so I think that's it. We have enough. So let's first figure out the area of A. What was A? A was basically this triangle right here, this guy. Let's figure out that area. Area of A is 1/2 base times height. Well, what's the base? Well, the base is basically from here to here, correct? And that is basically 2h. Since this was h, it's just double that. So 2h, and h is x over 2 root 3. And then the height, if you want to call this the height, is the same distance as from there to there, which is x over 2. So there is the area of A in terms of x. Let's simplify this. We're going to get x squared over 4 root 3. Now let's figure out the area of B. What was B, if you remember? B we had denoted as this guy right here, right there. That was B. So I'll write that in there like this, B. Okay, the area of that is very similar in terms of a triangle formula, 1/2 base times height. The base is this whole thing right there, which is x. The height was from there to there, which we calculated as h, and h is right over here. It's x over 2 root 3. And if you simplify this, it becomes x squared over 4 root 3. So now we have B in terms of x, we have A in terms of x, and we are almost done. Just go back and use this formula right here, and we can then solve for AS. So 2A plus B is equal to 6, and then our shaded region is 6A. So 2A plus B is equal to 6. So we've got 2 times A, which is right here, x squared over 4 root 3, plus B, which is right here, which is x squared over 4 root 3, is equal to 6. So this becomes 3x squared over 4 root 3 is equal to 6. And if you cross multiply, you get 3x squared is equal to 24 root 3. And therefore x squared is equal to 8 root 3. And then finally, our shaded region was equal to 6A. So area of shaded region is 6A. Okay? 6 times A is right here, x squared over 4 root 3. X squared we just figured out was 8 root 3, like that. And looks like the root 3's cancel. 8 divided by 4 is 2, so this becomes 6 times 2, which is 12. So the area of that shaded region is 12. This shaded region right here. At the Big Top Circus, Herc, the human cannonball, is fired out of the cannon at ground level. For the safety of the spectators, the cannon is partially buried in the sand floor. Herc's trajectory is a parabola until he catches the vertical safety net on his way down at point B. Point B is 64 meters directly above C on the floor of the tent. If Herc reaches a maximum height of 100 directly above a point 30 meters from the cannon, determine the horizontal distance from the cannon to the net. So what we will do is we'll take exactly what they gave us and we'll put it on a coordinate axis as follows. So I'll make the origin the point of the Canon. So that's 0, 0. And that's where he's going to be shot out from. And we will make this point 30 on the x-axis, corresponding to this point right here. And I will make, obviously, the parabola hit its peak right here. And that, if you look on the y-axis, it will correspond to 100. And then basically point C, it's approximately somewhere here. So I'll call that C right there. And we know that the parabola hits the point C64 right here. C64. So I'll put the same thing on my graph, approximately here. And then I'll connect the dots. So his trajectory is basically something like that. Now the good news is, because it's on a graph now, we can label these points. This is C64. This point right here is 30, 100. And this point we already labeled as 0, 0. Okay? So that is basically the setup of the diagram. Now, what is it that they're asking? What do we want to figure out? Determine the horizontal distance from the Canon to the net. So this is the net right here, and this is the Canon. So they want you to figure out this distance right here. Basically, the C coordinate on our graph. So they want you to figure out the distance right here from the origin to the C coordinate. So I will basically write find C. Okay, so let's now proceed with our question. We know that basically all parabolas have the form y is equal to ax squared plus bx plus c. Now, we don't know any of these a, b, and c's yet, but we have several points. We have 0, 0, we have 30 and 100, and we have C 64. Now, the good news is we can also figure out one more point. And that point is where this graph crosses the x-axis right here, approximately, right? Because if it kept going down, eventually it's going to cross the x-axis once more. Now, how do you figure out that point? Well, it's basically equidistant from 30. So if 30 was the midpoint right here, it's basically where you reach the height of the parabola from there to there. Then from there to there is 30. So from 30 to its other x-intercept will also be 30. So therefore this has to be 60. So 60, 0 basically is another point on the graph. So we're going to use 0, 0, 30, 100, and 60, 0 to basically figure out the a, b, and c coefficients of our parabola formula. So first, let's substitute 0, 0, and that would basically give me 0 plus 0 plus c, and therefore, very quickly, figure out c is 0. Okay, that definitely helps. So we are just left with y is equal to ax squared plus bx. Okay, let's substitute the next one, which is 30 and 100. So 100 is equal to a 30 squared plus b times 30, like that. And this becomes 100 is equal to 900a plus 30b. And then we'll substitute the next point, which is 60, 0, into the same equation. And that gives us 0 is equal to a 60 squared plus b times 60. So this basically becomes 60 squared, which is 3600a plus 60b. And there you go. We got two equations, we got two variables, and we can figure that out. I'll call this one, say, 1 and this equation 2. And let's go with this. So if I take this equation 2 and subtract from it 2 times 1, I should be able to get rid of the b's. So on this side it will be 0 minus 200, like that. And on this side it will be 3600a plus 60b minus 1800a minus 60b. And as planned, the 60b's cancel, and this basically becomes 1800a is equal to minus 200, and therefore a is equal to minus 200 over 1800, and a is therefore negative 1 over 9. Alright, so we got this guy. Now we just need to figure out b. B we can figure out by substituting a into either one of these. So I'll just substitute it, say, into, I don't know, this one. It doesn't really matter, either one. So 0 is equal to 3600 times negative 1 over 9. Like that. Plus 60b. Bring this over to the other side. And this becomes 3600 divided by 9 is equal to 60b. This is 400 is 60b. And therefore b is equal to 400 over 60, which is reduced to 20 over 3. So there you go. We've got our parabola now, our formula right there. We got a and b. So let's write out our formula. Y is equal to ax squared plus bx. Y is equal to ax squared plus bx. And then now we have our final step, which is what? Go back to the diagram. We have to figure out C, right? C is a point on the graph, C64, C being the x-coordinate and 64 being the y-coordinate. So just plug that back into our parabola equation and we should be able to get C. So C is our x-coordinate, so I'll put that in there. And our y-coordinate was 64, correct? So here we go. Multiply through by 9. I think that should get rid of the fractions. So 9 times 64 is 576. That leaves us with just c squared, or minus c squared. And then 9 times 20 over 3, so 3 times 20, so plus 60c. Okay? Put everything on one side. Let's see what happens. Minus c squared plus 60c minus 576 equals 0. If I multiply through by negative 1, it'll be easier, I think. Minus 60c plus 576 equals 0. Now, can this be factored so I don't have to use a quadratic? C, 48 and 12. I think that should do it. 48 and 12, negative, negative. Yeah, negative, negative. There you go. So C is either 12 or 48. Now let's go back and see which one it could be. 12 or 48, right? Well, from the nature of this diagram, C is over here. So it can't be 12 because 12 is over here somewhere. So that means C can only be 48. So since C must be greater than 30, which was on the graph, C must equal 48. And there you have it. So going back and writing it out in the form that they want, determine the horizontal distance from the Canon to the net. The horizontal distance from the Canon to the net is 48 meters.